Hello friends, I'm Praveen and today I'm going to talk about some of the best practices when using pointers. Few people start programming with languages like Java or Python, and when they have a transition to C language, generally this transition isn't smooth. They think C is sort of annoying or a nightmare of a language. That's because C uses pointers. But what is more annoying with C language is the problems associated with pointers, the usage of pointers. For example, memory leaks, accessing null pointers, garbage values, and dangling pointers, so forth. So, what is a memory leak? So, when you're trying to dynamically allocate a memory and forget to free that memory, the operating system thinks that you're still using that memory, so it'll not use that memory anywhere. So the memory is slowly being, leaked out of the free space available. So let us look at this program. For example, before explaining this program, for example, I have an integer a local variable, or for example, integer b, another local variable. Okay, so when the scope of this function finishes, these local variables are, or the memory occupied by these variables are automatically deallocated by the compiler. But when you allocate memory using dynamic memory allocation, it becomes your responsibility to actually, free the memory. So if you do not do that, then you can possibly introduce the problem of memory leak in your programs, and this is not desirable. And that is why you see a few people saying that C language is dangerous. It does not handle pointers and memory too well. So first, let us look at the example of this memory leak. Okay, so I have two character pointers. The first pointer pointing to 50 bytes of memory, assuming the character occupies 1 byte of memory, and another pointer 50 bytes of memory. Okay, so look at this assignment. Pointer 2 equals pointer 1. So what happens with this assignment is the address of the first byte in this memory block is now being assigned to pointer 2. Or in a more simple terms, the memory block belonging to pointer 1 is now being pointed by pointer 2. Okay, so after this assignment, both pointer 1 and pointer 2 are pointing to the same memory block. So the problem associated with this assignment is the original contents of pointer 2 are being lost because you are doing a blind assignment, pointer 2 equal to pointer 1. You are not caring about the contents of pointer 2. So you can see a memory leak of 50 bytes of memory. So a better practice is, before assigning such pointers, you could actually free the memory of pointer 2. This would ensure that there will be no memory leak and you're carefully handling the memory. Okay, so let us look at another example of memory leak. Yeah, so in this example, you can see there's a double pointer, char star star pointer, or you can call this a pointer to a pointer, or you can also call this as pointer to strings. So now I have two pointers being allocated in this star star pointer. So the first pointer allocation of 50 bytes of memory, and the second pointer also has an allocation of 50 bytes of memory. Okay, now if I try to free the pointer, okay, so what happens with this statement is this memory is deallocated. That is, the memory that it occupies is just two character pointers. This is deallocated, but unfortunately this memory will not be deallocated, pointer 0 and pointer 1. So in such a situation, it is better to actually deallocate first the children and then the parent. For example, I can write this program as I is equal to 0, I less than 2, I plus plus, free pointer of I, and then call free of pointer. So this will ensure that first the children will be deallocated and then the parent will be deallocated. So there will be no problems of memory leak in a program. So let us look at another example of memory leak. So in this example, I have a function func returning a character pointer. Inside this function, I create a new pointer and I return it. Now let us come back to the main function. So in this main function, I'm calling this function. Now this function is returning a pointer, but I'm not handling it. I'm not catching the pointer. So what happens is, even though this function is allocating 50 bytes of memory, I'm not storing it anywhere, or I'm not having any reference to this memory. So this also introduces another memory leak. So make sure that you actually handle the return types properly. For example, cat star return value is equal to function. So this will ensure that memory that is being returned by function is properly handled, is properly being held by a variable, and you can use it further. So this ends the three examples of memory leak, three possible ways of memory leak. Now let us look at dangling pointer example. So in this example, I have a function that returns the address of a local variable rather than the value of the variable. So I have a pointer in main function that actually catches the address returned by function. So the problem here is I am trying to return the address of A, which will be deallocated after the function goes out of scope. So I call this dangling pointer. So I'm trying to point to a location which is being deallocated. So let us see what will be the output of this program. So if you carefully look at this, A is being initialized to 5, returning the address of A, catching the value of the function, and then printing the value. So if it was not a dangling pointer, the expected output would be 5. But if you carefully look at this, it is 5. So why is this? First, let me do some modification to this program, and I'll explain later why is this so. In function 2, I have, so for example, another function, or make it white. I have some character A. Okay. Now, after dangling pointer assignment, I'm trying to call this function 2. Okay. So let us close this and try to re-execute this once again and see what will the output now. So if you look at this, this is some sort of a garbage value or some value which you cannot decipher. So why is this so? Why was it 5 in the first run and why is it some unknown value in the second run? This is because every function call creates a stack frame in the call stack. So these local variables are allocated in the stack frame, and immediately after this function goes out of scope, those variables are deallocated. So even though they are deallocated, the same memory location will still hold the value of the old values. I mean old variable values. So that is the reason why when you're trying to access A, you still can get the value of A. But for example, after the deallocation of function, now we are calling function 2. Now the same address that is being that was previously occupied by A will probably be occupied by some other local variables like this character or probably some internal variables or return addresses. So that is the reason why you will lose the value. You will lose the value, and here you see some unknown value. So dangling pointers are also undesirable. So you need to make sure that when you're returning some value, the value is not being deallocated. So so I think I made sense with my examples, dangling pointers and memory leaks. So thank you for watching the video.